Excellent, excellent. Last panel of the afternoon. I've been looking forward to this panel because scaling is our big issue. We do have one substitution. Wayne Vaughn, unfortunately, pulled his back. So we have in his stead Paul Sztorc. Paul is Director of Research at Tierion, but he is here in his capacity as inventor of DriveChain, which is a sidechain and fits nicely into the scaling conversation. And with that, PPS, over to you.
Thank you. First, I'd like to thank the organizers of this conference, PEMO, and I think this is the last panel, I guess. So I think it was a fantastically organized conference and a lot of interesting conversations throughout the day. We had investors, we had lawyers, we had journalists throughout the day, and a lot of talk about regulation. I think in one day, I have not heard so many lawyer disclaimers as I heard today. So it is completely filled with lawyer disclaimers. And for a change, this is going to be a technical panel. So it's going to be an interesting conversation to end the day. A lot of conversation today about tokens and the different types of tokens and where they are going to be used. But I think the key thing that obviously blockchain and Bitcoin introduced to us is pretty seminal in the aspect of providing immutable databases and bringing trust in untrusted peer-to-peer network. And obviously, there is a lot of that happening beyond just crypto. And the interest that I got into Bitcoin, into blockchain, was primarily how do I bring that kind of immutable database concepts into NoSQL and SQL databases. And as soon as we talk about that, we have to start talking about scale. And there is a lot of conversation about how do we bring scale, and a lot of research has been going on in that aspect. So we have this esteemed panel here that is going to try and walk us through that journey of what do we see today and what are the challenges we see today, and how are we going to kind of overcome these challenges. So with that, I would like to introduce the panel. I would say each one introduce themselves. So starting with Paul.
Thank you. Yes, I'm not the CEO of Tierion, but I am the research director. The CEO had an injury, as was mentioned. And I've presented at or been a part of the program committee for all the Scaling Bitcoin conferences as well. So I know a lot about this. And right before I worked in blockchain, I have to brag about something kind of cool because I was a statistician in the Yale Econ department, and I worked directly for a guy named William Nordhaus, who earlier this very day won the Nobel Prize in economics, so that's very cool. So I'm very happy for him. He's a super nice guy, very smart, so that's kind of a cool thing as well.
Divyesh?
Yeah, hi, I'm Divyesh Jadav. I'm with IBM Research. I'm not with IBM Blockchain, as the title says. I was a fill-in for somebody else. But IBM Research, as you all know, is IBM's R&D arm. We work very closely with all IBM divisions as well as outside industry. And my background is in high-performance computing and storage systems. And for the last few years, I've been working in an Internet of Things and blockchain solutions. And very happy to be here today.
James?
My name is Jason Barkeloo. I'm the founder and CEO of Knowbella Tech. This is my 5th startup, and this is after I had a military career. So I've got a little bit of a crazy background.
My name is Emin. I'm a professor at Cornell University, and I'm also a founder of, or one of the co-founders of bloxroute, and a founder of Ava Labs.
Hi, everyone. My name is Stephen. I'm the founder and the CEO of Harmony. We want to really bring what decentralization platform to the production level. We are really dealing with like 100,000 of machines. We do think that my background is from Google and Apple, bringing that production level to what blockchain can do today, not just really bringing all the best research idea to production is our mission.
Hi, my name is Mike Hahn. I'm the CTO of Splend. What we do is we power the blockchain with the network infrastructure. We created a technology called IBA. It stands for Integrated Blockchain Architecture. Our CEO and software engineer has 3 decades of hardware and software expertise. Our CEO sold his company to Intel. We have a team member on our team, so the National Semiconductor. You can see that we have a deep understanding of hardware and software, and basically we're looking to solve the scalability that we have today.
Thank you so much. So what we want to do is first start off with asking the question, is there a scaling problem, and what is the scaling problem in blockchain? And I'd like all of you guys to start describing what you guys think about the scaling problem in blockchains.
Well, I think the core of the matter is that the blockchain technology relies on this idea of consensus, which is total agreement down to the last byte. It's 100% complete and total agreement. So it's kind of, since everyone has to be in the exact same situation, the whole network can only go as slow as, or as fast as the slowest person. So everyone has to get there together, and this creates kind of disagreement over how fast everyone should be going, and so it ends up being kind of a big conversation about exactly what can be done to make it really easy for the slow people to catch up, or should we just leave them behind, or what should we do? And so that kind of opens this big political nut, which I think is the real heart of the matter. Is this consensus idea of total agreement down to the last byte. That's the way I see the problems all start from there, and they travel in a lot of different directions at once.
So I agree with that. The fact that blockchains are heavily decentralized and you need the consensus amongst all the participants is one problem that causes scalability issues. I think another aspect of it is the fact that you could have permissioned blockchains or public blockchains like Bitcoin. And in a public blockchain such as Bitcoin, because none of the parties are trusted, extra effort needs to be spent to make sure that transactions that they are submitting are valid. On the other hand, if you look at a permissioned blockchain like maybe Hyperledger Fabric, there is an inherent trust model amongst the participants in the blockchain, and that solves some aspects of scalability.
So I have a kind of a little different take on it. Of course, there's technological issues here that significantly hinder the scale, no doubt about that. This problem with being early ranges from everything about the slowness of doing transactions in a distributed model all the way through to lack of tools. There's also a human resources component. I mean, try to find a good qualified person that can go to work on a blockchain. Talk about scale. If you're a blockchain programmer right now, man, it's like back in 1990s when you were doing HTML and you could command a $150,000 salary to throw up a little stupid website. So I think that it ranges from that simplicity of at the human resources level to the regulatory level, which I'm not going to opine on anymore. That's been beaten around pretty well. But I think there's also the issues of the tools. There's a significant shortage of tools. I think that's one of the reasons why some of the funders are really focused on the tools, because that'll be the next big push in order to get to a point where we can begin to build these applications that everybody can understand and can use, which comes to the final piece that I'd mentioned, which is the lack of the user interface across the board. And I think people are even talking about standards at this point. I think anybody talking about standards right now for this thing is really off the mark. We're a long way away from being able to talk about standards.
So let's see. So the bright folks to my right touched upon a wide range of topics. Let me try to summarize what I think I heard. Essentially, I think at the core of the problem lies the fact that people have been sold a dream, and the technology that we have for that dream and the sort of the ecosystem around that technology is nowhere near enough to live up to the dream that we sold to people. If Venezuela were to switch to Bitcoin tomorrow, every single adult Venezuelan gets to go to the store once every 36 days. Okay, so you go and buy a packet of gum, then you can't go buy anything else for another month. That's crazy. That's the scaling problem. We need to get this technology into the hands of people who can use it, and we need to reach scales that are not only on par with fiat. I don't understand why Visa is our comparison point for all these technologies. 2,000 transactions is nothing. That's just where we should be to begin with. 2,000 TPS, that is transactions per second. But we should surpass it. We can and should build much higher transactions per second capable systems, and we should go and build the sort of the technology for tomorrow, where we have Internet of Things devices that can transact at hundreds of thousands of transactions per second. And so this is going to require a complete rethink of what we're doing. And in 5 to 10 years, the kinds of systems that we're going to see are going to look nothing like what we have today. So that's my starting point.
I will also ask scaling at what scale? I think centralized companies did already very well at getting hundreds of millions of users, if not billion of users. To me, the next technology that really will bring difference and breakthrough to everyone will be really scaling for even 10 billion people in the future. Can a technology really scale at that level is what we are thinking a lot about. Back to the question of what technology need to do that. I think big companies already solved that with like tens, hundreds of like backend servers and cluster of computing. Most solutions out there in the decentralizing, sharding, and scaling space still talking about like a few tens, if not 100 of machines working together. I want to ask, can we get back to what Bitcoin and Ethereum has done? They're dealing with 50,000, if not 100 of machines, production level scale of scaling. The last question that I want to bring out touches on what other speakers mentioned about the human aspect and tools aspect. My PhD is in language design. To me, expressing the smart contract to each other, between humans, is what I care a lot about. You can even like think about how to express your contract, specify what you really agreeing up on. Really doesn't make sense to write a smart contract that will break or like be hacked in a few months. So that to me is also a very critical scaling problem in order to bring more application into the space and usage.
So I'm the last person on the panel. And basically, we're all talking about the same thing, scalability at the top layer. Most company today is working on scalability on the software layer, which you look at the stack, which is at the application layer. Here at Splend, what we're trying to do is basically not taking a look at the top layer of the application, but bringing it down to the media layer on the OSI stack. So you look at Cisco. Cisco was the pioneer of the internet revolution. Why? Because they were able to route the traffic, route all the protocol, and now we're taking that expertise, bringing it down to the hardware layer, and basically now optimizing on the software. And that's how we're going to do scalability. Scalability right now, yes, you can say 100,000, a million transactions per second, but at the end of the day, can you bring mass adoption? And that's going to be a different subject that I would like to discuss. And it doesn't matter how fast you can do it. If you don't bring mass adoption into your solution, your scalability is going to be on the shelf.
Yeah, I think we brought out a lot of different aspects, technology aspects. I think Jason brought out the people aspects, the tool aspects, the hardware aspect, whereas the software aspect. We talked about billions of people. But if you were here a couple of hours ago when the investors or the VCs, there was a panel of the VCs, and they talked about all the challenges they have with people trying to build out scale when the applications are not yet there, or the applications don't exist. Why do we need to build things for 1 billion users? Why do we need to build things for hundreds of thousands of transactions? We get all these examples. Again, the Visa example is a standard example. Everybody keeps talking about Visa. But today, the Bitcoin ecosystem does like 2 transactions per second. Why do we care today? And what applications excite you guys? And does there exist applications that are there today that are suffering from scale? I'm just going to go randomly.
we shouldn't keep doing it.
Yeah, let me jump into this one. I think this is very, very simple. We can't possibly sit on top of this technology with the performance point that we're at today. We need to do scale just so we can show that we can do scale. So one of the most devastating impediments to adoption is this perception that blockchains are essentially a slower version of databases. But in fact, there may be two nuanced views of this. One not so nuanced view says this blockchain stuff, it's just like a regular database, but it's much slower. There's nothing really too exciting about it. So there's that. And then the other one is, well, you could always do scale, and there's some truth to both of these views. You could always do scale at the cost of decentralization. So you've all heard of both of these viewpoints, and they make sense. It's true that at the moment, the technology that we have is very, very slow. It's a huge problem. And at the moment, many of the proposed ideas for scaling up involve making an enormous trade-off from that which we hold sacred, which is decentralization, lack of control. We all understand that if I were to turn Bitcoin into my private database, I could easily do 100,000 transactions per second in a heartbeat, and that would not be a problem. Of course, there'd be no value in anybody holding that coin. So those two things are really problematic, and we need to address them head on. And the only way that I know to address this head on is to say, look, we can still hold these values. We can still build completely decentralized networks that do not suffer from the bottlenecks that we see today. We don't have to make this trade-off, and we can reach this level. So I think it's imperative that we show that we're capable of scaling without necessarily having the applications in there in the first place.
I definitely want to top that up. Many of us, as a matter of fact, my whole team of 8 people just went to China to have similar conversation like that. Many people can't even imagine putting their business or applications on top of blockchain, cannot test it. They cannot deploy it today. We need to get to a level, let's say our first talking point is actually how to build a decentralized linking. We can imagine what that means, right? Like you can access linking without logging in, you pay all these recruiter fees and all of that, what it means, but we cannot test it now. We really need to bring up to the level of at least 100,000 TPS, right? So that people can actually start testing it now. Every partners we talk to when we're in China keep telling us, you better deploy it now so that we can actually test out the application within our team with a realistic pilot.
So I think the transactional nature and limits of transactional scalability come into the picture when you have write-intensive applications. But there are a broad class of applications that do not really need a lot of writes, but rely on trusted information for read type of applications. So I think that's an area where we will see a lot of manifestations of blockchain technology. And you know, as a point of reference, today IBM made generally available the Food Trust Network. I don't know how many of you heard about it. We announced Carrefour, which is a global grocery company with 33,000 locations that's going to use this network for registering trusted information with respect to products sold branded by itself. And also Walmart is going to use the same network for certifying the origin of green leafy vegetables. So there are applications at scale that are happening. The important thing is many of them don't really need right type of updates, and so then transactional throughput is not that big of an issue.
Any other examples of applications that you guys see that are exciting, that makes a lot of sense? I mean, read applications, yes, but the fundamental value proposition of a immutable database is that it becomes immutable to writes, and that's where some of the capabilities come out, that people bring in a lot of untrusted transactions, and the immutability brings the trust in the system, right? So any other applications that you guys can think of? I don't know.
I think one of the biggest ones that comes to my mind, I've got a pretty deep background in trusted computing, is maintenance and control of your own identity. I just think somebody was talking earlier today about millennials and they don't really care about their privacy and that sort of thing. But you know, I'm of the position that this is the most fundamental human right, to be able to control your own identity. And if you give up that right, the unintended consequences are really significant. So the one big blockchain application that I'm of the position of that can be revolutionary to everything, nothing against green leafy vegetables, but is secure, is your control of your identity.
So I find that, I often find myself in discussions where somebody is asking me, what's the big killer app? And my typical answer to that question is, there doesn't need to be a killer app. This hunt for that elusive killer app is typically something that kind of waylays people away from the central point. So if you think about the internet revolution, the killer app turned out to be essentially just messaging and email, right? It was the most prosaic, most boring of applications. That's what really caused people to really buy into the internet. That thing grew because people could email each other, could send cat pics and so forth. So in the same fashion, I think blockchain applications don't have to be fancy. If I can just send money without the entanglement of the banking system, I think that's a huge plus. If I can create tokens that correspond to land records, to people here, maybe it's not that big a deal, but ask anybody who has any connection to any country outside the first world, and there's a big difference going to sleep knowing that the land records are not being tampered with versus always having some kind of doubt about your own government and about the way the society functions. And I can go on and on. Supply chains, of course, have been mentioned. Identity management has been mentioned. One of my favorite example application areas is insurance. Look at how tall their buildings are and look at the value add that they provide. It's an inherently peer-to-peer application. And do they really, deserve all this? I don't know. It seems to me that we can do better and much more cheaply. And I can go on and on, as I mentioned, but I won't. As I said, it's not going to be some fancy application. It's not going to be FOMO 3D that really makes this. It's not going to be CryptoKitties. It might very well be something super boring, and boring things are great. We should have more boring, less dramas per second in the blockchain space, more boring applications, and they will, of course, all require scale to get there.
Yeah, I completely agree with that. There's no reason to knock payments as the application. I think if anyone familiar with the numbers would see like this, it's just a huge amount of wealth being exchanged and just a huge amount of value for the consumer, and that in all its different forms across digital asset kind of world, as Dr. Sayer just discussed. You can have stuff like bonds or digital assets or these other things, and that's just huge. I mean, Forex is foreign exchange market is something like $5 trillion per day, which is like an absurd amount. But even if you just look at the Bitcoin exchanges today, you just see these huge volumes. Coinbase at a multi-billion-dollar valuation. It's like you kind of don't really need anything else, I think.
So another way to look at application is ask yourself, why don't you trust a particular big company right now? Obviously, you don't want to write down your salary information on your LinkedIn profile, but why? When we were in China, no one used Tinder. They worry about being discovered among their friends and family. That level of controlling your own digital life is really, really ready. I have my data, I'll disclose to certain people. Doesn't matter how it works. You hesitate every time clicking on the accept terms is the best way to think about what ready to be used today on blockchain.
Yeah, basically all of these apps are amazing. I read an article a couple weeks ago where it's saying that EOS and Ethereum today only has 8 apps, which only has 300 active users on their platform. And now we're talking about scalability. We're talking about all of these, but we only have 8 apps. That's 300. It's crazy. You know what I'm saying? So boil back to mass adoption. You know what I'm saying? We need the user base. We need the mass adoption. So once you have the mass adoption, then scalability will come in. So for example, at Splend, we signed a deal with CCTV that has 200 million households in China. With that amount of users, now scalability will come in. It's very important to bring in the user. Once you get the user, then the killer app will come in. You know what I'm saying? That there's tons of applications out there, but there's no users. So that's what I think we have to solve right now. Once we get the mass adoption, the scalability will come into play.
Great set of points. I totally agree with Iman as well that there is all innovation, be the internet, be the mobile broadband space, everything, the innovation was done, and then there were these killer apps that appeared that obviously in retrospect, you now say that, hey, this is the technology that can enable that, right? And so you have to do the invention and the innovation in advance. So great set of points there. So the next question I have is, I know Mike has been talking about, and Stephen, and all of you have been working in the space. What are the great innovations that you think are enabling the scaling, and what are the things that you think is either your company is doing or some other company is doing that can actually make this scale go to 1 billion users, to hundreds of thousands of transactions, to billions of dollars of foreign exchange being transacted on that on a blockchain platform, or identity being managed for 2.5 billion users, or whatever the size of the user base will be of large-scale platforms. Any thoughts?
I can start. So at bloxroute, the main area where we are addressing scalability is at the layer 0. That is the network layer underneath the consensus protocols. So if you imagine a world where we've actually advanced the science of consensus protocols to new protocols that are much more aggressive about how to achieve consensus, to bring different nodes in sync, then you will find that the bottleneck lies at the network layer. So this is something that we have seen in our lab over and over again. Every time we simulate sort of advanced protocols, we find that, okay, well, once you solve the protocol layer problems, you find yourself bottlenecked at the network. So bloxroute is a company that's looking at how to make data transmission super fast. I think of it as sort of the Akamai for blockchains. Its job is to take small, timely, high-value financial data and to send it on to whoever might be interested in it. This might be transactions going one way, blocks going the other way for a traditional cryptocurrency, but it could be any other data as well. So we use a lot of technologies that were initially invented for the internet, adopted now to the overlays and the blockchain technologies that we see. And we are seeing enormous speed ups as a result. You can run your blockchains at much higher throughputs by virtue of using better layer 0, and you even out the advantages that big miners have or closely coupled miner groups might have. So you prohibit the formation of cartels and you preserve that critical decentralization. So that's bloxroute. I'm also, as I mentioned, founder for Ava, and the Ava coin is using this new consensus protocol. In about 40 plus years of research on consensus protocols, we've only seen 3 families of consensus protocols. We've seen Nakamoto consensus. Everybody knows how cool that is, invented by Satoshi Nakamoto in 2009. Before then, we had classical consensus protocols. There are thousands of papers on this topic. They're not good for open admission, so Nakamoto had to come in. But they form the foundation of private blockchains, and the people who invented that field, Leslie Lamport and Barbara Liskov, and many other people who follow them, Lamport and Liskov both have a Turing Award each. So these were the 2 families. And just this May came a paper called Avalanche that shows a 3rd new way of achieving consensus that gets rid of much of the bottleneck on that critical consensus layer. And it allows thousands, if not more, people to be part of the consensus protocol. We don't need any mining. We don't need essentially the equivalent of Chinese miners burning energy. And it gets rid of the expenditure of energy in the background. No value needs to leak out of the system. So I think with these 2 approaches, we're going to be getting rid of the bottlenecks at both layer 0 in the network and at layer 1 in the consensus layer. And after that, it's up to smart contracts and applications built on top.
At Harmony, we really take the approach of really bringing the best research to production level. To us, the idea of what Oracle has done, taking the relationship database idea to building one of the largest company, if not what Google, taking the end-to-end approach, taking all the research idea, again, to production level, right? Very few crypto projects really bring it up the largest scale production level, ready for most secure, most performance requirement today. We are very serious about a sharding approach because time in time, really where the distributed system or database really need to take it, hey, now that we have 100,000 machines, what do we do with it to really do that level of deploy? The second thing that we're really tackling is really understand how language design can really allow the idea. It's not just about an enterprise trying to dump all the data on the blockchain. It's how you and I have a trust issue and all this escrow, if not notary, that we need to talk about specifying the agreement between us. Can formal verification get somewhere? Can a different language has to be better than Solidity? It's like writing Perl back in the day for internet. To me, that's the analogy, right? It cannot be the last language that we would talk about like billions of people dealing with all the digital and consensus agreement in the future.
I totally agree with Network Zero. Network Zero is the bottleneck. And once we solve the Network Zero and all the protocol on top of it, the application will flow in. So I totally agree on that, and that's what we're working on at Splend.
So yeah, I think we talked about the network layer, the hardware layer, and optimizing applications. All of those have a role to play. But I think the consensus layer, I think that's where the biggest gains will come in achieving performance. And some concepts over there, in addition to what Aaron said, are, sharding is something that's becoming very popular these days. Another approach would be to just minimize the number of nodes that are involved in consensus, as the notion of endorsing peers in Hyperledger, and also maybe minimizing the amount of work that is actually done on the blockchain. So it's a more of a data distribution model over there that might see a lot of value.
So also getting into permissioned versus non-permissioned is another aspect.
Absolutely, yeah. I mean, that is a fundamental difference. I think permissioned versus non-permissioned, there's a huge difference in the amount of work that needs to be done to arrive at consensus.
Do you have an open source modification to Bitcoin that lets you send Bitcoin to other software applications and then get it back safely? So it does kind of circumvent the consensus issue that I mentioned before, because if you want to go very quickly, you can leave and go with a different group of people, and then you can all go very quickly. And then as the money changes hands, those other people can walk it back to the main Bitcoin chain if they want to do that. So this is it's a sidechains technology that I call Drive Chain, and it's at drivechain.info. And we released last week, and we have like a great community of testers already, and we got some cool stuff. So you can find most of it at drivechain.info, I think. So it's pretty cool, I think.
So mine's a little different. We're not about R&D. I'm not going to let my team engineer us into oblivion. Our job is to build a sustainable revenue-generating company that provides my investors with an ROI. And if you start getting lost into the blockchain or AWS or any of these enabling technologies, and that's all it is, it's an enabling technology. If you get lost in that weed, you end up doing great and wonderful things that ends up nowhere, ends up in the pantheon of failures from a market perspective. And so I kind of implore that it's important that you have these understandings of what's happening at the engineering level, at the R&D level, but at the same time recognize that there are certain companies that are going to do really, really well in that area, and you got to pick, am I going to go down that path or am I not going to go down that path? So in my company, all we care about is using them. Just making sure that if it makes sense, we use blockchain. If it doesn't make sense, we're on AWS. So for us, it's a very hybrid approach. And for some folks, they think everything is on the blockchain. Everything's got to be moved to the blockchain. For me, I'm not of that position. So I'm really kind of backing up from my peers here who are really talking at the engineering level. And I'm more of talking about why it's important to branch beyond just the engineering, understand what's going to happen in the market with this wonderful amount of engineering that's being done.
So we all know that there is a scaling issue today, and we recognize that certain applications cannot work on the blockchain today because of the scaling issues. I know Divyesh mentioned a little bit of the trade-off that we can do. Are there other trade-offs that we are thinking about? Like, for example, permission versus non-permission. Are people thinking about does everything has to be a public blockchain, or can there be private blockchains that we can think about that can solve certain problems? what are the kind of trade-offs that you guys are thinking about? I mean, and to Jason's point, is everything going to be, we can't just like block on technology. We have to, there are business problems, there are challenges in the business today where, like Emin said, there are countries that don't have title deeds and records. Like, are there abilities today that we can do that trade off certain things that you guys are thinking, hey, this is a valid trade-off to do and something that, a blockchain would be applicable to?
So, okay, let me take a stab at this because distributed systems are full of trade-offs. Right? This is a well-known situation. There's no such thing as free lunch. Typically, to get something, you need to pay for it in some other fashion. Having said that, let me also mention that's not universally true. Like, there are also technologies that are strictly better than others, right? And typically we find that the very first instance of a technology is typically not the best instance of that technology, right? So MySpace was not the best social network. We're not on it anymore, and it does get replaced. So there is such a thing as dominating, as some technologies dominate others. But there are many trade-offs, and I can identify a few that I've seen. A very common one that I touched upon earlier is a trade-off of decentralization versus performance. We see this all the time. I can go to, EOS is exploring some of this. I can go down that path and have, 21 trusted, block producers, or I can go down to, 5. Of course, if I go down to 1, I can have great performance. So that's personally a direction that I'm not interested in, but that's a large space. We're going to see many other coins explore that whole area on the continuum from coins as we know them, and AWS on the other extreme. We're going to see many, many tries there, and I'm interested in none of them personally, but some people are. We will also see more subtle trade-offs, again in the negative direction. There is typically a privacy versus efficiency trade-off. Right? So Zcash, for example, pays a huge cost to try to give you some anonymity. And there are other such trade-offs, like Lightning Network, for example, to route effectively has to actually poll the network and figure out the financial relationships between network members. And so that reveals information about when you receive payments, when you send payments to other people with whom you have close economic ties. So there is a fundamental trade-off there, and I worry about these trade-offs. I worry that to gain efficiency, we are giving something up that's valuable. So these worry me, and there are ways of actually scaling without having to sell your soul. You do not have to necessarily decide between your daughter versus your son. You can actually say, well, look, I'm going to focus on building better technologies at the very, very lowest layers, such that I don't find myself forced into a false dichotomy, a false need to give something up. So that's why I'm excited about both bloxroute and Ava.
To me, it's not just about trading off revenue or even technical trade-offs. It's really about how do you build the future. My trade-off to me is trading off to build a centralized team first. Getting the Fuse pilot from the enterprise space first. I would say 10 years ago, it's a cyberpunk movement. Why don't we open source? Why don't we get the community excited, fully decentralized, no one in the same place? Right now, finally, all my Googler and Apple friends are excited to do like blockchain for a good reason. We're a bunch of like large-scale infrastructure engineers that are very serious about bringing to production. Right? Why the entire team of 8 of us went to China is we really need to understand the market, the community there, and not to like specialize in certain region or work with only a few partners, but doing the pilots first will really get you very deep in the business use case. And having a centralized team will get you a little bit further away than all the projects that said, hey, day one, I'm decentralized already, no one is in the same office, that didn't get any work done. That didn't bring us to the large scale production of like really deploying in a, can you ever compete with Google, if not even LinkedIn? To me, that's our trade-off.
So, something to ponder about is, can we trade off trust for efficiency? So if you look at, using the plastic credit card, right? We have an account with a credit card company. We do an onboarding. They do some kind of background check when we sign up for one. and then they allow us to spend money on it, right? And they're trusting that we are going to pay the bill at the end of the day. So in blockchain systems, a lot of effort is expended to establish trust between the parties. So maybe there is some notion of trading off that trust, and so that you go ahead and accept a transaction in good faith. And if the other party is malicious or non-trustworthy or defaults, then you have mechanisms in place to overturn it. That's something to think about.
The question was about trade-offs, and I think I agree with Emin that, there are all these trade-offs, but what you really want to do is not trade off on something. You really just want better ideas that. So if you're in like the tech world and you're in the world of science and R&D, which I don't know, but if you are in that world, then you're not really in like the trade-offs world. You're just trying to just beat everything at once. Try to do a completely new thing that doesn't trade off on any old things. So I think that's really what's going to make the big difference. For the world today versus the world in blockchain 3 years from now, there will be totally new things that it won't just be like an old thing with the parameter moved over here versus over there.
Well, there's also going to be this natural evolution that's going to occur. For me, it's about simplicity. At the end of the day, the more complex it is, the more difficult it's going to be to scale. And let me give you a great example. How many are you old enough to remember VHS and Betamax, right? So, I said that to my son. He's like, huh? I said, you ever heard of an 8-track tape? He had no idea what I was talking about. The point of the matter that I'm making here is that not the best is always going to win. The simplicity is generally what's going to run the day. So Betamax, I had that. I had VHS. I loved Betamax, couldn't stand VHS, but the only movies I could get were on VHS. So at the end of the day, we're sitting here with this idea of how do we scale, and I have to look at what's going to be the simplest way to go, and the simpler it is, the easier it's going to be to monetize it, to get it out into the market space. And the other one that I'll bring up is modems versus where we are today. Good gosh. The leaps that we made just in the modems to where we are today is incredibly significant. And who would have ever dreamed that modems were going to disappear, right? We thought modems were going to be around forever, and you're just going to increase the baud rate.
So we have, this is going to be the last question before I open up to the audience. We have a pretty esteemed panel here. We have people from the industry, from research, from academia, all angles of the community that is trying to innovate. What do you guys see as the innovation that will change, or where do you see the scaling in like 3 to 5 years for blockchain? Start all the way to the end.
For me, scalability, basically, we need to collaborate. All the research, all the paper, there's, why reinvent the wheel when everyone is tackling the same scalability? That basically we need to collaborate as a group. Blockchain is decentralized, but at the end of the day, we're all tackling the same problem.
Looking 3-5 years out, I have to every day keep thinking about what is the application that billion users will use, but they don't use it today. Otherwise, all the big companies are going to take care of us right now, right? But you can tell, whether about data privacy, whether about having AI data marketplace, that people don't trust each other, but they can put the data together, and each data has no value, but it's about millions of users, thousands of machine learners contributing to a model. It's the only way possible. These are the applications that got me excited why I'm building companies for 4, 5, if not 10 years, because just trust me, big companies already make it to billion users level now. To really capture what Bitcoin has done, day one, everyone can use in the world, is what excites me every day.
Great. So let's see. My vision is quite simple. I think 5 to 10 years from now, we're going to see a great consolidation. At the moment, we have about 1,800 coins. At last I checked. It's insane. Many of those coins have provide zero value other than to the people who created the coins. So we're going to see most of them disappear. And at the very bottom layer, I see that as a consensus protocol, Avalanche is capable of delivering at the level that the dream that's been sold to the masses. And I think it's going to eradicate a lot of these minor coins, and they're going to just have to move to something much better, and Avalanche is going to be that better thing. And in fact, these major coins should also will also be threatened by it, if not replaced by it. So that's at the consensus layer. When you do that, you find that the network layer is the bottleneck, and we're going to see innovative approaches on the network layer as well. And when it comes to the second layer, my view is not that your regular person is going to be connected to a layer 2 solution, but that there will be solutions for people who transact frequently. So between exchanges and so forth, you might very well have a drive chain. You might very well have a replacement for the main chain because you actually transact very frequently together. So we'll see a range of innovation, mostly at the consensus layer and below. And there will be, at the moment, I see only a few contenders at layer 2. We'll see those developed. Layer 2 is interesting, but it's not a consumer technology. In my view, it's way too complicated and complex for regular users. And the problems are unsolved. And as far as I know, not solved in academia. So I have no hope that they're going to be solved quickly in practice itself.
So 3 to 5 years out, right? So let me pull out my little crystal ball here, and I'm going to make everybody in this room billions and billions of dollars. All right. Plastics. So, when I think about what we're going through right now, it's a very disruptive period of time, and every day, every one of us that's in space sees something new. There's just something that happens. And I think what we're going to see in 3 to 5 years is another disruption. I think that we're talking today about blockchain. I think in 3 to 5 years, we're going to be talking about something else that this has stimulated. That's what I think we're going to see.
That's a very good point. And I encourage everybody to look at Plastic Bank in that context. Okay, so coming back to my answer, I think I have two answers. So one in the consumer space and maybe one in the enterprise space. So in the consumer space, I think it will be identity management. It's used, by billions of people all over the world for accessing any kind of online service. And I think blockchain has a fundamental part over there, which, if our scalability problems are resolved, I think will be an extremely valuable implementation of blockchain technology. In the enterprise space, I think it'll be in the area of trade and finance. So for finance, for fintech, it would be in transactions amongst big financial institutions like pre- and post-trade settlement, cross-border payments, things like that. And in the trade world, it'll be the supply chain, where you will see a lot of applications of blockchain technology.
It is very difficult to predict the future, of course. But if you ask me, we will be able to do payments that are much higher, 10 times more frequent than Visa, so 10 times the transactions per second of Visa. There will be stock and bond market, digital asset kind of markets. So we'll have like a stock market and like a bond market, and we'll even have lots of financial derivatives of existing kinds that are like put, call options, et cetera, but we'll also have new ones that would be like prediction market type things. And there will probably be some kind of identity thing, but I think really the big thing will just be that the payments thing has taken over. And you can just look at the historical growth of Bitcoin, the price of Bitcoin, the interest in the technology. More people will get involved. The rate of innovation is like super geometric. So there's tons and tons of new people getting involved all the time. They splinter off and they find their own little area. And so there will be huge amounts of transformative change. And already the seeds have been planted of just crazy growth. So we don't know exactly what form the scale will take, but we know that there's big interest and a lot of people are doing a lot of things, and some will inevitably be successful. And it's now like it's gotten to the point where so many people are doing things that you can't even make like an up-to-date list of what all the things that people are working on, even in one or two categories. So it's only the real bottleneck is just waiting for the public to figure out that the problem has been solved. I think it's the longest stage in the process.
With that, I will open up the floor for the audience questions.
So there was a point made on trade-offs and simplicity and how we choose and do things. You know, you mentioned old enough about VHS and beta. I remember RSS versus ICE, which was a more complex standard for subscription and content management. We see this in the technology stacks where OSI and what's the one we have now? What was the competitive OSI? What do we have now? HTTP and okay. Bottom line is that we often make bad choices that we don't learn about till later. With RSS, the content was free. Now we worry about copyright. With HTTP, we didn't include payments, so all these free models emerged, but there was no payment channel there, or there was, just was never implemented appropriately. So how do we do a better job at our trade-off selection versus the simplicity trade-off? It's like, yes, simplicity is always the easy thing to get adoption, but may not be long-term the thing we really want. But I'll leave that to you guys to settle.
But don't you think like we have no choice but to do the, the dumber thing or something? It's like that's just the way. That's just kind of what. See, you laying out the scenario, and it just seems like why wouldn't it keep? That would, I guess, in the blockchain world, that would be like the larger blocks, more centralized, cheaper payments scenario, less decentralization. But I don't know. The only solution, right, is to innovate fast enough to let everyone get what they want. Right? Yeah, that's all you can do is try to have the better ideas as fast as possible. It's kind of vague, I guess.
So I only have one solution to all of this. It's a generic answer, but it's, I think, exactly answers your question, which is we have to adopt a more scientific approach for the discussions. That's all we have to do. It sounds like a really simple sort of a panacea or whatever. It's not a panacea. It really will get at the problem, but it's actually not simple. It's very, very difficult. Often you see political interests come in. Often you see all sorts of strange things employed to get the public on your side. You find narratives pushed. You find the scientific approach pushed to the wayside, and sort of sound bites take over and so forth. But if you force the people who are making these trade-offs or who are pushing the one traded off thing onto the public to actually enunciate why they chose that thing, to come up with simulations, feasibility studies, and similar things that actually motivate the solution at hand, then we're going to find that we make much more intelligent trade-offs.
So another approach would be to make things modular, right? So there are many different elements of a blockchain system, like the consensus protocol or the validation phase or the ordering phase. I think by having a modular architecture where you can replace or put in a new protocol or a new implementation for all of these components is one way to get around being locked into an implementation. And then in a larger context, to promote standardization and interoperability, as was recently announced between Ethereum and Hyperledger.
Yeah, I'm just going to add to his point. Occam's razor, maximum principle. If you can't focus on those, you're lost.
I was talking before, and I was thinking about your project, Emin. The key innovation, as I understand it, is random sampling. And so I guess I'm just interested to hear a little bit more about that magic and how do you come up with how do you get true randomization? That's actually a hard problem.
So this is a question about Avalanche's random sampled voting. So it turns out that in Avalanche, you do not need sort of global randomness, which is a critical property. So Avalanche could, but does not, audit nodes. There's no need. People can misbehave, and we don't go after someone and say, who did you poll? How did you pick them? Did you really pick them at random, and so forth? We let them do whatever they want. If they use a bad source of randomness, they are more likely to be fooled themselves, but they can do no harm to the system. So that's our simple approach of dealing with this, and trying to get away from the global randomness generation problem, which is a really hard problem, as you point out. We don't have that in Ava at all.
Any more questions? Okay, with that, first of all, I would like to thank the panel. It was a fantastic panel. Thank you, everybody, and Paul also for stepping in at the last moment.
And this last panel did not disappoint. I expected high caliber commentary and got it. I learned new things. And thank you all for staying through the day. And we were really excited to have you. Pemo, maybe some closing words?
And thank you, Pierre.
Thank you. Awesome. All right.